We will now work on a more realistic scene and take a look into some very important attributes of the RBD objects. So I have prepared this simple scene with a grid object as a ground plane, a very simple bridge, and a camera and a few lights just in case you want to render your exercise. So let's dive into the bridge geometry. You will notice I have already pre-fractured the object. So as usual, I'm using the RBD material fracture node. So let's activate the smooth and wire shaded, just for you to see the pieces. Of course, if you want, you can lay down an RBD exploded view. And for now, I'm using very simple detail. I'm not adding the chips or the interior detail that I would usually use in production, just to make things a little bit faster. So let's go back to my material fracture node. I will set up my camera again. And I will connect an RBD bullet solver. So with my RBD material fracture node, press Tab and start typing RBD bullet solver. And once you select the node you want to connect, you can Shift Enter to lay that node and make it connect automatically with the node that was selected. In this case, the RBD material fracture. For this exercise, I will disconnect the constraints. So press Y and Shift. And let's press play just to see what happens. So remember, by default, the RBD bullet solver is adding gravity, and you can take a look here in the forces. This is the force pulling the bridge downward. And as we did on the last exercise, we could add a ground plane just to make this more natural and make the pieces collide with something. So let's press play. Of course, I will always use a real-time toggle when I'm generating simulations. So what I want to do next is only make the center part of the bridge collapse. And actually I want to animate the bridge so it starts breaking here on the left side and gradually starts falling more towards the right. So before I start setting this up, I will save the geometry and then start simulating. So this is something I would actually do in production. Once I'm happy with the fractured object, I would save that object to disk, and this way I don't have to generate the fracturing every time I open the file or every time I do a change here on my data tree. So I will add an RBD IO node, which is also a new node and is specially created to save all the data that comes from an RBD material fracture node. So it will save the high resolution geometry, the constraints, and also the low resolution geometry, all in one single go. So I will connect all three outputs to this node. And another thing that I like to do is color the input nodes and output nodes with blue. And I will also color the RBD bullet solver with this orange. And after the RBD IO, I will connect the node to the actual solver. So here is where I'm going to save the geometry. And I will save the file in the HIP folder. So wherever this HIP file is, it will generate a geo folder in case you don't have the geo folder already made. And then it will add the name of this node to the file and a frame prefix in case you're doing an animation. In this case, I will just save a single frame of the geometry. I don't need the frame variable. And I also don't want to add the HIP name to the name of the file. I just want to add the name of the node with the BGO extension. So make sure to change the frame range to save current frame only. And now you can click on Save to Disk. Once the file has been saved to disk, you can click on Load from Disk, and the file will be automatically loaded. So now we can start configuring our RBD. Just a quick note, I realized that I left the default name here on the RBD.io and saved the file. So remember, since we're saving the file with the OS function, it will use the name of this node on the saved file. So I changed the name of this node and resaved my geometry. And again, it's loading it from the disk. So let's continue now. I will add an RBD configure node, and I will connect this node just below my fractured geo. And what I'm going to do with this node is to change the active attribute for these pieces. And the active attribute is something very important that tells the solver which pieces are going to react and which pieces are going to be ignored. So let me disconnect the constraints, activate my RBD bullet solver, and press play. So for now, nothing really has changed. If you take a look at the RBD configure and scroll down, you will notice that by default, all the pieces have the active attribute to 1. So this means that all the pieces are being calculated in the sim. So I'm going to toggle this checkbox for the active attribute and change its value to 0. And let's see what happens. Again, I'll press play. And you'll notice how now none of the pieces are falling down. So what I'm going to do is to selectively change the active attribute only for the pieces that I want to react to the simulation. And this can be achieved in many ways. We could animate this attribute. For example, let's create a keyframe with value 0. And then on frame 25, let's change the value to 1. So this would effectively turn on the pieces after frame 24, and all of the pieces would start falling. Another thing that we can do is create a bounding box only in the part of the pieces that we want to fall. So I will Shift Control click on the active attribute just to delete this keyframe. I will leave the active value to 1 and click on this checkbox that's called Use Bounds. So what this checkbox will do is take into account this bounding type that by default is bounding geometry. So for now, I will change the bounding type to bounding box. And here I can control the size of this bounding box and the positioning. So I will bring it up and I will make it larger, just so most of the center pieces are within the bounding box. And let's try playing the simulation again. So you'll notice now the rest of the bridge is holding together and only the pieces that are within the bounding box are falling. So let's now combine both techniques to make a more interesting simulation. So I will keyframe the bounding box to make the pieces start falling from left to right gradually. So I will go to my RBD configure node. I will change the size and the position of this bounding box. And actually in frame 1, I will create a keyframe for both properties. So you can alt click in size and then alt click in center to create a few keyframes. And I will make this bounding box very tiny. So I will push it towards the left. So I have this left pieces active on frame 1. Then I will go to frame 48. Just before doing this, you may want to click here on this button called Disable Simulation. And on frame 48, we will grow this bounding box till it touches the rightmost parts of the bridge. So let's scroll the timeline, and you'll watch this bounding box growing from frame 1 to frame 48. So let's simulate this and take a look at the result. So again, toggle the Disable Simulation button and press play. So this is looking much nicer. I may want to extend the animation to make the progression slower. So you can shift, click and drag on your timeline to select a keyframe, and then with the middle mouse button, click and drag to the right. So in this case, I'll just move it more or less to frame 96 and again simulate. So this is more what I had in mind. Of course, you can experiment with the speed of the animation or with the length of the bounding box. For this exercise, I'm happy with the result. The only thing I'm going to do is increase the resolution of the geometry, save again the geometry file, and make my final simulation. So let's do that together. I will go back to my RBD material fracture node. I will turn on chipping, and this may take a while depending on the amount of pieces that you have. And I will also turn on the detail. So this will increase the look of the geometry. Okay, so it took over 2 minutes to generate the edge detail. Of course, it will be worth it, but this part is where I think that the old methods, the traditional methods, are a bit faster. So again, you can take a look at volume 1, where we created some Boolean fracturing. At some point, if your geometry is very complex, you may decide to go on that route rather than using the RBD material fracture. But it's good to know all the pros and cons of each workflow and each technique, so you can later decide which one you want to use. So let's generate our final simulation. I will go back to my RBD bullet solver and press play. Of course, we may need to resave the file. I forgot to go into my RBD.io and save to disk. It's still using the old geometry. So once the new geometry is saved, you can go back to the RBD solver and again press play. So this time around the simulation took much longer. So I took the liberty to create a flipbook, and this is the end result. Of course, it's looking much nicer with the interior detail and the chipping. Depending on your computer, it may take a few minutes, but I think it's worth it. And just in case you haven't done flipbooks yet, I will disconnect this flipbook here. And you can go here on the flipbook button, click here on the flip with new settings. And what I did is change the end frame and change the final resolution of the flipbook and just hit start.